Welcome, Internet, to another episode of Makers on Tap, podcast where makerspace directors drink and talk about making stuff. And today we have a super fun episode for you that got a little messed up, and we weren't even drinking. Aaron's on.
Yep.
And we had Sanjay Mortimer from E3D on, and an hour and 15 minutes into the episode, his laptop died and we lost his audio. But I was recording backup audio, so we have a not so good version of the episode that's missing the first 10 minutes of the episode or so. So
par for the course.
We're gonna run with it because it was really good, and I think it would be hard to get that level of genuine conversation again, right?
Yep.
Yeah. So if you're listening and you have a better way of recording episodes than what we're doing for getting remote, interested in hearing it. It's just the ones we've tried before haven't worked any better than what we're doing now. So what you missed at the very beginning of the episode, picture it. Sanjay letting a very adorable dachshund outside that's named Heatbreak. Heatbreak extrudes poop. We have a long conversation about extrudate and poop. And then we start talking about their launch today of ASMBL, or ASMBL, which is the additive manufacturing / subtractive manufacturing hybridization that's happening with the toolchanger. And Sanjay is talking about the beginning where it's very connect, and the ASMBL plugin, which is in Fusion 360, and a modern slicer. That's pretty much what you missed. Right? Anything else?
I don't know. I can't hear when we cut it. So
yeah, and because we're recording desktop audio, anytime that also got captured. I'm really sorry about that, but this was a really fun episode, and hopefully you guys can tolerate it. If not, we'll have Sanjay on again, and we'll try again. Let us know on the Twitters. Here it is.
Tool changes and where the subtractive paths need to be inserted so that they happen in the right order, and mix them all together, and then basically spit you out a G-code file that you can then upload to Duet Web Control and hit go on. I'm grossly simplifying the process, and it will go ahead and print a layer and cut a layer and print a layer and cut a layer, or you might even print 4 layers and then cut in one pass and print 4 layers and cut in one pass. There are lots of knobs and levers to play with, but it essentially is hybrid in very much the truest sense of the word. It is not machining. We're not talking about, you cannot take a block of plastic, put it in a tool changer, and then go cut yourself apart. I mean, maybe you could, but it would be a really bad way of achieving that goal. A 3D printer is not stiff enough. The spindle is not high power enough to get any kind of reasonable material removal rate.
Right.
However, with FDM, the only bit that we need to cut away is that kind of nasty knobbly surface on the outside, and maybe some boogers or layer change zits and stuff like that. That's all we need to do. So this does us a massive favor. We only have to go along and skim away like a couple hundred mic at most of material in order to get the geometry that we want and surface finish that we want. So we can get away with a very stiff 3D printer. A toolchanger, by 3D printing standards, is an extremely stiff 3D printer. However, by machining standards, it is like a leaf in the wind.
Yeah, it's a bendy noodle.
Yeah. So, however, like the fact that we only need to go along and skim, what is a couple of hundred microns in X, Y, and Z, and we're just taking a very light pass off the sides, means that we can get away with much less rigid mechanics. And that is really, really cool, because it means that cut a long story short, you can create parts, you can design parts with almost all of the design flexibility of FDM. And it also massively simplifies the CAM process, because you're always adding a layer at a time and then trimming it back. You don't have collision detection concerns. So unless you want to do some fancy 3D surfacing, which I might add you can also actually do, but you have to know a little bit about CAM and ordering and stuff, but that's totally doable, and the plugin will assist you in doing that. But if you just want to print a layer, trim it back to size, print another layer, trim it back to size, then it basically trivializes the CAM process into a couple of clicks. And what you get out are parts that they're smooth, they are shiny, you can specify a transition fit, clearance fit, or interference fit and get it reliably on bearings and shafts and inserts. You can get sharp corners, right? Something that you just can't do in FDM, right? You always end up with a natural radius. Where we're squeezing out a fluid, you can't really get a sharp fluid. It's not a thing that happens. And so when your fluid that can't be sharp sets, it sets into a geometry that also is not sharp. But when you come back and you trim it with a cutter, you can cut it to knife edge geometries and all that good stuff. Things that we haven't tried yet, but we think you can do is, and it's probably almost trivial, things like very small engravings, so like tiny little features that you couldn't otherwise get for either decorative purposes or, like ribs and texturing and that kind of stuff. You want to add a very small crosshatch for grip or those kind of things. So,
things like part
I think
numbers, maybe.
I think the ultimate goal is to get parts that have equivalent quality to a machined or even very close to injection molded part, but with the simplicity in terms of the CAM process and also design freedom that FDM affords you. And that's a big deal, because that's like best of both worlds ability to create geometries and finishes and qualities of part that have never been possible. A lot of the time you get stuck between a rock and a hard place, because you have to choose between, do I machine this object and get great surface finish, but quite limited design freedom, or do I print it, get great design freedom, but end up with poor surface finish and tolerances and so on and so forth. And this knocks a lot of those problems on the head. It's definitely in a nascent state, like it's early stages. You can do, but the really neat thing is that Fusion 360 now has FDM slicing in it. Again, like it's not the most advanced slicer out there yet, but it means that you can have like a couple of click workflow that's all inside your design environment. And
And that's just wonderful.
Yeah. And I, I'll be damned if Fusion aren't working on putting things like, they've got the entire team behind HSM Works. They're like the people that invented trochoidal milling.
Mm-hmm.
If you're a machining nerd like I am, then, you know that they have talent there. And I'll be damned if they can't figure out how to put a G2 or G3 arc from a step file. Or not, it's not a step file. They have the native geometry that you designed.
Yes.
And they have the ability to turn that directly into additive G-code, which is super neat and cool. And then turn it, with the plugin helping everything mush together, you can do that. And we can already mix in, trochoidal milling, adaptive clearing, all that good stuff. And not just adaptive clearing, but all of those fancy 3D surfacing paths that one uses. You can see some of that in the blog. It's just really neat because machining's had, like a 50-year head, or CNC machining in particular, has had about a 50-year head start on us, about the 60s, 50s, 60s, depending on how you count it. And that means that that there's this really incredibly mature tool chain that is in Fusion 360 and many other tools out there. And so we basically just have to get the slices that we already have to work with those systems. And it's not that hard of a problem to figure out, now I've printed the layer, I need to come along and machine it. So we get to leverage all of that and mix it with all the great work that's being done in the open source community out there. And so our plugin, I don't mean to demean it because it does some really cool stuff, but it's basically taking those two worlds and mixing them together so that we can get the best parts of additive and the best parts of subtractive. And you can put them into one part.
Yeah.
That was a very long introduction to what ASMBL is. Additive, subtractive, manufacturing by layer.
Aaron hates your name, by the way.
Yeah. Not the biggest fan.
A lot. I kind of made it up. I kind of made it up as like a bit of a troll joke, because obviously, it's not assembling anything; it's cutting stuff away. But then the marketing team were like, "Yeah, that's good," and all the engineers like, "Oh, cringe." But what are you going to do?
It's not assembling anything. What?
Yeah, I know, dude. It hurts me too. But the more controversy it generates, the better. And here's why. Our objective here is we're not going to become millionaires off of, open quotes, inventing hybrid FDM. Some people have done it and what have you. But finally we have the pieces only just kind of came into place. Mm-hmm. We have Fusion 360, which has a plugin architecture and a mature CAM tool system, and the API in the plugin system lets us get in there and muck around with the subtractive stuff. And we have slices, they're already made, and they're all fantastic. And now we also have a tool-changing 3D printer. It was the bringing together of those things, and we're gonna all of the code for the plugin. And when I say plugin, it's not just a plugin. It actually runs standalone, so you can take G-code from any slicer, and if you configure your post correctly, you can take Mastercam, you can take Esprit, you can take whatever, and you can mix G-code files from any subtractive. I say any, but if you can configure a post, which if the CAM package doesn't let you configure a post, then it's not a CAM package. You can take pretty much any subtractive package and pretty much any FDM slicer, open source or proprietary, and you can squeeze those G codes together to produce yourself some hybrid goodness. And all that code to do so is open source. So basically, we hope people steal our idea, and like, frankly, there's very, like in Autodesk, I would be happy if tomorrow they announce, oh yeah, like we also do that now. And
they will.
The code's been,
that's what they do.
Yeah, for sure. And it's to show people the way. The code's being released open source under a permissive license that lets people integrate it or use it as a library in proprietary software. So if Mastercam want to, like roll it into their kind of post workflow and what have you, then like we're game. Like go forth. Like we just, this for us has been a passion project that's gone on for quite some time now. Like we're an extrusion systems company, and the best case scenario for us is we show that, we know what we're doing and we're competent and cool engineers. It generates some notoriety for us as a company. And hopefully I would like to help other companies tool change, and along the way sell them components for tool changing systems and stuff like that. But there's no way in hell you're going to see E3D making a fully integrated tool changing 3D printer with built-in CAM workflow thing where you just upload your step file into the cloud, and then off you go, and the magic microwave 10 hours later pops you out a perfectly surface finished part. But that's not our bag.
But that's how CNC machines and 3D printers work, right? You take a picture of your part and you put it in the machine, and you close the door and you hit the bing, and then a few hours later your part comes out, right?
It's not that hard, guys. Come on, you say go.
Yeah, I mean, you can also draw your part on Paint and then run that straight in also. So that works.
So you mentioned that you've open sourced the plugin code, and you're okay with other companies or programs integrating it into their systems.
Yeah.
What are your long-term plans for that plugin project? Like, for instance, are you open to like community pull requests to like help enhance it, improve it?
Yeah. The less we have to do to achieve the same objectives, the better. And also, I think that there are people out there that are, the guy who's written this. He's so damn smart, it blows my mind. But he is a mechanical engineer by trade, not a software dev. And so, yes, getting. I think that there are people out there, the types of people that have written slices and contributed to slices are going to be incredibly well placed to contribute to that and help us write it better, smarter, the whole deal. There is no considering the objectives that were just previously stated, why on earth would we not do that? It would be insane to refuse help. So,
yeah, I was curious about Andy's background because I was taking a look through the code base earlier, and it's a pretty good first start. Like you've got a solid, starting point for this. And I see some areas for improvement. And I was just curious what your plans were for the project long term. Because like if you're going to keep it around long term and just keep running it, keep maintaining it as a project, then I already have some ideas I could help submit some pull requests for it. But
yeah.
if you're just going to like throw it out there, be like, here it is, here we go. Then like if that's it, then it's like, well, I don't know if I should spend the time on it.
Well, then you should fork it and make it better.
No. Well, pull requests are in, but we're really bad at choosing open source licenses. I'm not sure which license it's released under.
LGPL 3.0.
Good. Because I think that before it was just like the default one. And I think that LGPL is a good license for the objectives of this project, but I'm not good at license. So, yeah, we want people to be able to use it as a library, contribute to it as a library, but not take it and modify it and keep that to themselves and integrate it into their program without giving back. We want people to be able to use this open source library and link to it from proprietary software, so that big companies in the CAM world can get involved, and companies like Simplify 3D can offer some kind of a system to let it plug in and so on and so forth. Yeah. But it's so I think it seems like the fair and logical choice of how to do this. And pull request away.
Sweet.
Rad.
So I was reading through the documentation for the plugin, and it says specifically not to remove the raft unless you know what you're doing, because you'll very easily just drive the bit into your heat bed. How many beds were ruined during development from that?
I've been absolutely flabbergasted at the ability for certain carbide tooling to actually machine, for certain values of the term machining, glass. It's like, I have a glass, a few glass plates that, they actually have you can see like a chip happened here, and there's a track, and we got a good 30 millimeters into this part as we're ramping down in before the bit broke. But it blows my mind that you can get through just even a couple of millimeters of glass.
Oh yeah,
but yeah, it's blasting away, doing its thing. So yes, many.
Interesting.
Have you successfully?
In fact, we actually have signs. We have signs that go on the lab doors for when ASMBL is running, so that people absolutely do not enter the workshop without wearing safety goggles.
Have you successfully gotten through the glass and machined a bed yet? Well, we've broken the beds. If that counts as getting through, I mean, we created a feature that fully bisects the plane. It goes all the way through the plane of the bed. So, is that machining through a bed? I think so.
So now you can plane your heat bed, tram to your to your gantry.
That I like. Hardware leveling.
Yes. Yes. Yes.
Yeah. So especially if you're using Ultem, that's actually, that'll work.
Yeah. Oh yeah, you get a really a nice thick sheet, or like a Garolite. You could do that with Garolite too.
Yeah. Garolite and nylon. Garolite machine's nice.
It does.
Or Tufnol, as we call it in the UK. It's got cute brand names in the queue. There's Tufnol whale and Tufnol bear. They're named after animals. It's hilarious.
That and Perspex. It's acrylic here. It's no fun. Perspex is great.
Oh, do you not call it perspex?
No.
Ah. Amazing.
We have broken Sanjay.
Yeah. So,
Yeah, so I'm really excited for this. Gave me a little bit early, and I immediately for the toolhead, and I have one GT2 pulley that has been sitting in limbo for 2.5 weeks, coming from China. I should have paid more than 52 cents for it.
Oh.
But the other option for that pulley is $36, and because of the shipping from the UK. So I haven't pulled the trigger on the $36. I might today.
Oh, dude, I'm sorry.
Is that for the BLDC motor?
Yeah, it's got a 3mm shaft. So I have printed a 3mm to 5mm bushing to accommodate a pulley that I have here, and we're going to try that out. But the next step is figuring out how to hook the ESC to the Duet, because Greg created these great instructions for how to build the tool, but no instructions for how to deal with the software and firmware side. Nothing at all. So that's
Oh, Lord.
that's my funsies for this weekend, probably.
Yeah, I don't know. If you ask Greg, yeah, we should get the firmware.
I love.
We should create a version or something on our GitHub for that.
He said he'd send it to me when he got a. I love asking Greg questions, though, because he's one of those people where, like, if you ask him something, but you don't directly ask him specifically how to do it, he's just like, yeah, I know how to do that. and then he'll just disappear for like 2 days. It's like,
Oh, man. Oh, you've no idea. Yes. I love Greg. He's, yeah.
yeah.
You ask him a question, and it's like, have you ever been on that subreddit, like, our malicious compliance?
Yes.
Yeah. It's like he answers your question. It's like, yes, Greg, that is an answer to my question, but clearly it was not an answer to the, this is not helpful with the intent of my inquiry.
Well, I'm really glad that it's not just me.
Oh, no. He's,
Am I so dumb?
Yeah.
Greg's just not going to answer me on purpose?
No. He does that, yes. even to the smartest people we have at E3D, it's not you're not being discriminated against or judged. Greg disdains all humans equally.
That's amazing. All right. Well, that's good. So yeah, my iAssemble head is in my tool changer today. I don't know. I have spent the last week and a half bringing my tool changer up to the retail standard and trying to do the most beautiful wiring job I can, and that I have successfully defeated the PT100s. Apparently, they do not like being ran in a shielded jacket with stepper signals, because as soon as you turn the stepper, it sends a short signal back to the Duet. There is no electrical short, but just that stepper signal will short out a 2-wire PT100 configuration.
Yeah.
So
Just crosstalk.
learned that. But running 2 wires outside the jacket, completely screwing up my beauty.
Yeah. It's we definitely need to get on the 4-wire PT100 and PT1000 game.
Yeah. Why aren't those in stock, Sanjay?
Because with so many things to do.
I tried. So so many things to do. What else are you doing? You released titanium Hemera heat brakes the day after I built all my Hemera tool heads.
Sorry, dude. All right, Hemera's got a good excess of cooling, so you should be legit there.
Right.
The
The blinginess.
Yeah. Cool factor on.
I know they're stainless steel, and that's crap. Anyway, what else are you doing?
What does the titanium give you?
Titanium has thermal conductivity that's significantly lower than stainless steel, especially if you pick the right grade. So stainless steel 303 that we use is 16.4 watts per meter Kelvin to the -1, whereas the specific grade of titanium that we use is 6.7 WMK. So it's it's notably less than half the thermal conductivity
So does that
of
prevent
stainless.
heat creep or reduce it?
Yeah, it reduces the conductive load on the cooling side. So, I don't know. Let's say you want to use a quieter fan, or you have like some kind of condition that makes your cooling more marginal, such as enclosure either of the whole printer, or you're kind of packaging the extruder inside of some kind of like boxy structure for either industrial design purposes if you're a printer manufacturer or similar. It really helps you out there. The other thing that it does is got a notably higher flexural stress at yield compared to 303. I forget the stats, but I think it's at least 1.5x, probably maybe creeping up on 2. 303s are around, they're just like it's sub 1000 MPa. I'm pretty sure the titanium's above 1000 MPa. So it gets you basically a heat break that has a high resistance to being bent as well.
So for those that didn't catch that, it's harder to break them, and you get less heat creep.
Yeah, sorry, wrong answer.
Those are my favorite Sanjay answers. It's just, people and thinking.
Well, yeah. Yeah. You didn't get me on the podcast for the short answers, right?
Absolutely not.
Yeah, I know a lot of our listeners aren't engineers like me. So I had no idea what titanium gave you over stainless. Like, why would I want that? So
it also has a lower surface energy, so it's less sticky. So you get melty PLA in there, it's less likely to stick.
Interesting.
Yeah, and also for some reason that I really can't figure, because titanium is notably less machinable on paper than 303, but the surface finishes. If you ever look inside of a titanium heat break that we make, and I think it's a product of the fact that you have to wind back your feeds and speed. Very long answer, but they're shinier on the inside. So, in addition to the lower surface energy for your PLA to do the adhesion parts, in terms of the tribology, the adhesion governs the static friction, the stiction, the surface energy, and things gets you more that stick slip behavior, that catch and then release. But the surface finish that we're able to achieve also has an impact on stiction, but it also decreases the running friction as well. So it's a smoother extrusion experience, which is actually particularly helpful on Bowdens. So stiction on Bowdens is what gets you those slight kind of delays in restart and stuff like that. So yeah,
nice. Speaking of,
you're a real extrusion nerd.
We got to do the extrusion podcast, man. Seriously, it's going to be fun. Three
Yeah,
people
extreme.
will listen to it, but I'll be entertained and it'll be a good time. Speaking of Bowden, you guys sent me a little hot end a little while ago. Can we talk about that?
Yeah. And so
You're like, no.
I guess
I hate you. Maybe.
without going into the specifics, because it's actually changed a fair bit in scope since the thing that we sent you. But I guess the realization is that V6 has a lot of things that are like that because of how things were and the limitations that we had a long time ago when we designed V6. But and if you buy a standard V6, it's not like quite the best hot end we could possibly make if you pulled out all of the stops, like budget wise and stuff like that. So I'm going to get in so much trouble for talking about this, but I guess, like for the titanium heat break example, if you have a heat break that transmits less heat, then if you have less heat, then it's going to be, you're going to have lower cooling requirements, and that has impacts on your heat sink and your fan, and those impacts are, also positive. And also we've got better at like heating stuff up and making heaters, and there are a whole bunch of things. And yeah, you can come along and buy a titanium heat break, and that'll help in a whole bunch of circumstances. But it's still a V6, and you can even replace, all of the parts with the best parts that we make in that class, but it's still a V6. But if you start from the beginning and say, we know how to do all of these things now, what does that allow us to do in a hot end? That's where we're going with that thing that we sent you, even pre-alpha of what it will be in the future.
Okay. Interesting. All right. So
yeah,
you drove. You said future.
Yeah.
What's in the future?
And so I guess that's like part of the whole kind of philosophy for what we do in the future. And I'm not even trying to be elusive here, but we don't even know precisely what all of that looks like in terms of a product lineup. But at the moment, we're putting a great deal of R&D into really going back to the fundamentals of how you make a hot end or you make an extruder, and starting with like physics first, and then also the constraints of reasonable manufacturing processes. What we can do now that A, we know a great deal more, and B, we have a great deal more scale.
Okay.
And yeah, what are the objectives? I guess when you look at something like Hemera, it's pretty close to the limits of what physics lets you do with a around 1.75 millimeter filament. And so in terms of extrusion performance, I wouldn't expect an enormous forward leap in just the fundamentals of extrusion are still the same. Like you're still heating up filament inside a tube, right? And without getting really, really crazy, that's going to be the same for a little while going forwards. But what we can do is radically change the scalability and cost of these systems. And we can also radically change the usability of these systems as well along the way. And so those are the real focuses in the future. If we look at the market that's out there as it is, E3D is a company that wants to sell extrusion systems. We don't want to just sell extrusion systems to the high-end to super high-end, high-cost players, or into the high-cost machines. And it was unfortunate that a great example of this is, and I hold no animosity for the fact that we didn't make it into the Prusa Mini as a mainline extruder. Like, those guys they saw exactly the same needs as I'm spouting now. They wanted a machine that is easy to use, so they created a whole new electronic system with a new user interface, and they wanted a machine that was low cost. And so, a whole E3D extrusion system is not, cost-wise, is not yet compatible with that objective. And there's, no way that we're ever going to be able to go out there and go, hey, Creality, here's your, you're selling that $250 Ender machine, and you're shifting God knows how many out there. Would you like to put $110 extrusion system on that? Would you like to do that? Obviously the answer is going to be no.
Yeah.
But if we can create systems that do not compromise performance in any way, and in fact will improve upon it, if we can create systems that are cost compatible with the future trend towards low cost machines, then we're going to be able to access and put what we do, which is high performance extrusion. That means you can print functional parts out of high performance materials with a high degree of reliability. If you can put that in the hands of more people, which clearly, if you reduce the cost, the accessibility is going to go up. That's just a given.
Right.
But the other corollary to that is that if we improve the financial accessibility, then we also need to improve the ease of the user experience, accessibility factor. We can't just ship someone a bag of bits and expect them to get it into their whichever machine they've bought it with. They want the machine to arrive ready.
Yeah.
And they also want whatever they buy in the aftermarket world to arrive ready, and hopefully just kind of like plug and play with that. And the only way that we can achieve that is to have systems that meet OEM's cost objectives, and also have systems that really put user interaction front and center.
Okay.
Yeah, I think that those are the objectives. I think that we're doing pretty well against those. There are still some big unsolved problems, and I wouldn't hold your breath for, in 2 or 3 months, E3D will have a whole new line of extrusion systems coming on out. That's not going to happen. We're talking about building out manufacturing processes and systems, and spinning up huge amounts of tooling and investment in those kind of things. And those are just building those systems and cutting those tools and what have you is a slow process in and of itself. But also the costs are so high that you spend a very long time making sure you get it down right. Because I can tell you from experience, it really smarts when you pay 10 grand for an injection mold tool, and then the injection mold tool's junk, and you have to trash it.
Mm-hmm.
It's not fun. So yeah, it's the best way I can put it is we're rewriting the book on how you make an extrusion system, starting with physics first. But really, the rules have changed since 2015 and 2016. The rules have changed. What people are, looking for has changed.
Yeah, definitely.
What we can afford to do because of scale has changed. The onus on us for quality and reliability has changed. A lot has changed. Physics hasn't changed, and so that's why performance and things that we've trended towards the fundamental limits of with systems like Hemera, we're not gonna double the performance of Hemera overnight.
No.
I think that there are a bunch of ways that we can improve on performance, but they're going to be incremental.
Mm-hmm.
But what we can revolutionize is how people look at their extrusion system in terms of how they interact with it on a daily basis, and we can also expand the accessibility to that high performance engineering plastic. Wouldn't it be freaking awesome if you could buy a Creality Ender 3 for $250 and off the shelf you could print glass reinforced nylon?
Yes, that would be amazing.
And I think that's perfectly possible. But it's going to require a lot of work.
Man, you went from being super manic and crazy to deep philosophical future sobering
Yeah,
Sanjay.
yeah.
So
It's,
As to like when you guys started E3D, did you guys ever at this point where we were having this conversation of like, I'm sure you thought about meeting me and building that out, but no, but like having this conversation where you're thinking about this future state where you're scaling at the level you're talking about scaling and all of that. Did you guys ever think that you were going to hit that? Was that even a thought?
no, man. Like, I wanted to make extra beer money for summer. We were like a couple of broke ass technology teachers, or I don't know, what you would call shop in the States, I guess.
Mm-hmm.
And when you're a teacher, you don't have much money, but you do have a fair bit of holiday. And so we thought, what are we going to do in the holiday? Because we can't afford to actually go on holiday. So we're like, we know how to make these like hot end things. And it seems that people want the ones that don't melt and can go to 300 degrees C. They seem to keep asking about that on the forum. So maybe if we like bought the parts to make a few and then like we put them together and stuff, we could sell them like maybe on eBay or on like a I even forget what it was called. It was basically like the Wix of e-commerce.
Okay.
It's kind of like a Shopify equivalent, maybe, or something. I can't even remember what it was. It was some very small company. I don't even know if they still exist. But yeah, and so we did that. We didn't even start a company until like several months later, as we're like panic ordering more hot hands because. So no is the answer. Definitely not. Business plan, none. Or business plan, we have nothing to do. Maybe if we make some hot hands and sell them, by next holiday we'll have enough money to go on holiday.
That seems like the way to do it.
That's literally all the thought that went into it.
Well, that's awesome.
Like, that's it. But yeah, I guess that's kind of cool. And I think the thing, I guess I consider myself like an entrepreneur by accident, or an unwilling entrepreneur, because I just want to build hot hands, right? But you have to do this thing involved in the selling of them in order to build more. It's very tedious and inconvenient. But I think the one piece of advice that I give to people when they're saying I want to start a business and I have this idea for a thing, it's like, don't invest any time or money or the effort of any kind into anything other than two things. Like, number one is product. Like, develop the technology or product that you are proposing that you're going to sell, and do nothing else until that product is better than the other things that are out there. And number two, find people that are smarter than you at the things that you're not so good at, and try and convince them to come along for the ride. I think that, like, Elon puts it quite well when he says, like, all a company is a group of people working towards a common goal. And the goal is oftentimes a product or a service or whatever. I don't know anything about those kinds of businesses. But But if you're, in the tech sector and you want to sell a product, make your product and find good people.
Nice.
Good advice.
Yeah. Well,
Like, don't even bother spending the, I don't know, in the UK it costs like 40 quid to incorporate a company at Company's House. Like, you don't need to start a company to make a product, right? Just build it.
yeah. 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 You don't need a website. You don't need a logo. Just go make your stuff.
Yep. Once you got stuff, then, people might want to buy it. But, yeah.
Yeah. It's hard. It's easy to get caught up in the minutia of all that stuff and be like, oh, well, I've got to do all.
Yeah.
Nah, just make your thing.
Yeah.
Make sure it's good.
Yeah. Yep. And this, like, a lot of people also get very caught up in like business models and pricing structures, and like, we want to do an offer here to expand our market over there. And it's like, in the physical products game, like, your job boils down to one very simple thing, which is you make a thing and then you sell it to people for more than it costs you to make that thing. And have to cover all the other costs that kind of go along the way and hopefully make a bit of a profit. And so you should make it really, really easy and straightforward for people to buy a thing. It's my pet peeve when it's like, you have a website for whatever amazing, fantastic, like, we have the most wonderful wire in the world. This is a real world experience. We have the most amazing high temperature wire in the world. And it does this, and it's abrasion resistant, and it has this minimum bend radius. And it's like, yes, I would love to buy your wire. And then you have to fill out like a contact inquiry form. And like, I'm very terse when I fill these things out because they piss me off. I'm always like, please send me pricing for product number this. And then they're like, we'd like to set up a call to talk about your application and your requirements. And I'm like, you make wire, like, you have wire, I have money, I would like to give you the money and for you to give me the wire. Yes. Anyway, we've got a long way from 3D printing now.
Infuriating. I'm dealing with that as well.
I'm sure every engineer out there, I would, if anyone out there is listening, I would just implore every company, even if you want to know about the applications and stuff, like, please just have a sample kit that I can buy for $50 plus shipping that contains, like, I don't know, if you sell wire, just like 2 or 3 meters of every single bit of wire you make in a nice box. And like, iGUS do an amazing job of this.
I was just going to say, iGUS, everyone should learn from iGUS.
Everyone should learn from iGUS. Like, they nail this. They absolutely nail it. And they give them out to you for free, which is all the better. But like, if you want a bit of an iGUS product or sample, like, if you're, an engineering company, you probably already have it downstairs, which is even better than having to order a sample from a website, right?
Yeah, along with a clippy magnet and a flathead screwdriver, which I don't understand.
Yeah,
this is a nice screwdriver.
Yeah. Their marketing department is, they're cool, really cool.
Have you ever tried to print their tribofilament? Like,
some
of them print okay,
but I only had
some of them are
really
garbage.
early. Yeah, I only had the really early, like, first one that they did.
It was real jammy, and then one just ran and bubbled real bad. Yeah. Anyway.
Yeah, I think early on they had problems with dispersion of what I assume are aramid fibers in the material, and it was like all clogging up. And yeah,
They said they fixed it. I talked to them at a trade show a few months ago before the world started burning. They were like, "Oh, it's much easier to work with now." But
yeah. Oh my god! I guess filament and ASMBL would be an incredible thing to mix together, right? Because you'd be able to get those like close running tolerances and surface finishes. I don't even thought of that. That is cool.
Yeah.
Yeah.
I want to see that. I want to see people making metal parts with the stuff that you sinter after you print. I want to see people doing that.
The BASF Ultrafuse.
Yeah.
Yeah. Not tried that either.
And I want there was another one that I really wanted to see people do stuff with.
I really want to. For me, I really want to see people do like the kind of combination of having material that like looks really great.
Mm-hmm.
So I don't know, sticking with it. So sticking with the like polyester family because they all bond, but you could have like a glorious external like PET beautiful metallic shiny glittery whatever external surface, and then on the inside have like carbon PET inside of there, and then but also polyesters come in like really flexible as well, and so like some kind of like compliant mechanism that like looks glorious and uses the amazing surface finishes, but also the close running tolerances and the stiffness of the carbon, just like combining the ability to do multi-material that tool changing gets you, but also with the subtractive glory of like surface finish and great fits and tolerances.
There's still a lot more I want to do with the glasses frames that I had at Earth. There's a lot more I want to do. I'm really...
Oh, yeah. That would make a big difference, man.
Yeah.
To get your lenses to fit.
Yeah. Yeah. There's so much. All right. We've been at this for an hour. A little over an hour. What else do you want to add? I want to bug you because you haven't made me a 3mm Hemera yet to put on all my lull spots.
Ooh, yeah. I would say probably don't hold your breath.
That was what I figured. But, still jibe. Still jibe.
Yeah, it would require...
It'd be a major engineering endeavor. Like, everything would need to change. At the very least, the heat sink and heat break would be a major change. And
the motor, because the motor has to, the bearing pockets have to align with the yada, yada, yada.
Yeah, I won't hold my breath for that one. We'll just print the hundreds of kilograms of 3mm filament I have and stop buying new.
Yeah, I'll go with a soft no on that one. I'm trying to think of a way like you could do some awful hack.
Run 3mm filament through a Philistruder and turn it into 175.
There is that. So maybe if you... Because the extents of an M4 thread, basically, I'm thinking of like some way to, you're a pretty talented machinist, and you probably have access to a lathe. I reckon that you could probably mill out the heat break hole to basically be an M6 tap. So you can tap it out M6 and then adapt a normal heat break in some way by turning down the outside so it'll poke out the top and and then you'll have to make hobs that are of basically a smaller diameter.
Yeah, no.
Yeah.
While this does sound like a really fun challenge, like if you're like a weekend project, it doesn't sound like a tool that I would want to try to use on a regular basis.
No, I don't think so. I don't think so. Yeah. We're not dropping support for 3mm filament, and we have new OEMs coming along that use 3mm filament.
Really?
And
okay.
Yeah. And so it's not something we're dropping support for. But 175mm really does lend itself to making small, compact extruders.
It does.
And
3mm really shines when you want to make big layers and big extrusion. That really shines there.
Yeah.
But when you want to make things tiny and cheap and fast,
yeah,
it does not.
Yeah. I'm working on some crazy things for fast. I don't know if they'll work. But I also don't know if I can actually manufacture them. But yeah. Well, we'll see. We'll see.
Good.
But in effect, at the moment, if you want to go faster, hot end wise, speaking, if you want to go faster, you just have to make your heater block longer or your melt zone longer, right? The bit that's the melting temperature longer. I think that there's probably ways that we can make a hot end that isn't longer, but still melts more plastic per second.
Yeah, we talked about.
Yeah,
that was a
I have a few different approaches. I'd rather not go into details on that one.
Nah.
But yeah, I give it like maybe a 30-40% chance of working.
Yeah.
Yeah.
All right. Well, Aaron, do you have any other questions that you want to get in while we have Sanjay?
No, I got all mine out.
Trying to think if there's anything super fun and cool. I don't know. I'd be interested to know what you guys like. For me, like looking out and like what things I've seen that are cool that aren't really in my domain. Like the thing I'm most excited about is these VXL support materials. I don't know if you've seen them. Gosh, I don't know how much I can say, but I don't know about the background. However, you know, if you've used Stratasys soluble supports, right?
Mm-hmm.
And they dissolve in alkali.
Yeah.
They have like hydroxyl groups on the side of the chain, and anyway. But as you know, like PVA, when you dissolve PVA, it doesn't really dissolve it. It kind of like
becomes a mass.
Gradually, turns into a slime. Whereas a Stratasys soluble support, it dissolves like salt, right?
Yeah,
like
it's like soap.
Yeah. It literally dissolves like to It's very, very clever, and it's because the polymer is literally reacting with the chemicals in the bath.
Yeah.
And I believe that they actually, I don't know if they depolymerize or there's chain scission, but anyway, it means it dissolves like soap. And so VXL, as I understand it, have some relationship to the company that invented the Stratasys soluble polymer, and they've come up with it is actually a totally new polymer, from what I understand, but it dissolves in the same way.
Okay.
So it's not the Stratasys product just like recycled.
Yeah.
They really invented something new. But it works fantastically with PET, and you can buy it like right now.
Like as
All
right.
Like you can go out there and you can buy it, and it's like the Stratasys soluble support experience, but it doesn't cost like $1,000 a kilo.
That's amazing.
Which is always convenient.
Yes.
I find.
Yeah, because I've even ran the Stratasys stuff on desktop printers, and it prints really good. It prints like PLA. Like it's just it's a very reasonable print experience. But
it's basically polystyrene, the Stratasys stuff.
Yeah, and if you're not a company and you don't want to buy their wash station, you can dissolve it with OxyClean. It doesn't work as good, but it works well.
Yeah.
I'm immediately, because glasses need soluble supports, and I want to print more glasses.
Yeah, and it's great. And I'm at the Meta Trade Show, and they're working on I forget which one is available now, but they're working on like higher and lower temperature variants, and these guys are like, it's not like they're reselling someone else's tech or like buying resin from a big company and spinning it into filament. Like, these guys are inventing polymers from scratch with like hyper novel properties. And then they're synthesizing them, and then they're compounding them, and then they're turning them into filament. And this is what I'm most excited about in our industry, is that this is happening. Because if you want to produce polymers at scale, the price of entry is like 100 to 150 million bucks minimum.
Yeah.
Right. That's just like,
it's like, very expensive.
Yeah. The setup cost it's more than that, because it's not just you have to have the money. You actually have to know how to build a synthesis plant for yourself. It's a really non-trivial endeavor. But now that we're starting to matter more to companies like DuPont and Eastman and like 3M and like GE and SABIC, and the list goes on. To have a company like DuPont come along and synthesize polymers from scratch for our application, which is what they're starting to do now, is going to make an enormous difference.
Yes.
Can't NDAs. We've been working with a different company in the past, and we were able to get in there, and we could tweak every knob, right? We could change the molecular weight distribution. We could change the customize the melt points. We could fiddle around with crystallization kinetics and like viscosity and adhesion. And this is a level of control that you can't get through compounding,
Mm-hmm.
which is when you take off-the-shelf polymers and resins and you mix them up, which is kind of like what we did with scaffold, right? So scaffold, we take a bunch of PVA and different additives and we mix them all up, and it means that we get a material that flows a bit better, sticks a bit better, dissolves a little bit better too. But it's not a revolution. And like, to put it bluntly, like VXL is better than scaffold.
Okay.
And there's no shame in saying that, because these guys have the knowledge and tools at their disposal to synthesize us a polymer from scratch that does these things. And so guys like you and I are kind of, unfortunately, a little bit out of luck, because there's no way that we can compete with that.
Right.
But it's also super cool because companies are going to come along and they're going to be able to do this. And we were able, by collaborating with this big name in industry, to take a polymer completely unprintable, absolutely completely unprintable, and make it print as well as the best 3D printing specific polycarbonates. It was amazing. And nylon's already a pretty printable material. What's DuPont going to be able to do? I mean, DuPont have been making nylon commercially for like 100 years. Like, this stuff was invented in like the 20s or 30s, I think. So they have like a little bit of experience here and a bit of a head start. And so, like, Tolman, watch out, right? Because these guys are going to be able to do this. VXL are going to be able to do that. And now we're getting big enough and important enough and trendy enough.
Yeah.
On the materials side, I'm really excited. Really, really excited.
I revolution. Everything is going to come from, like you said it before, we figured out how to move a print head around very accurately, and you guys know how to make plastic squirt out the little hole as good as we can. And the next step is making the materials better and better and better.
Yeah. I think, I agree with you very much on that front. I think, the 3 pillars of FDM are software, materials, and the kind of polymer processing aspects. And that, heated beds and other things, not just like print heads. But those are the 3 novel technologies. Because, the electronics, driving steppers is a known deal.
Yeah.
And
You're granted they'll get better, but like we've known how to move a thing around for a while.
Yeah. And the Duet guys have done incredible work, and there are many others that have done incredible work on the firmware side, and things like that. But motion control has been within humanity's reach for quite some time, and the firmware side as well. The electronics and firmware, and linear rails and Cartesian motion, or whichever other motion system you're a massive fundamentalist fanboy about, whichever you choose. I guarantee you're not the first person to be doing it, or the first industry.
Right.
And so I think it comes down to software, materials, and materials processing tech. And materials is, in my eyes, always been the one thing that hasn't had a whole lot of like real deep hardcore innovation. Like, it hasn't had that like physics first innovation. or chemistry first innovation,
Right.
and that's because of the cost of entry, and that's going away now, and that is, I think, the biggest change that I saw at the most recent round of trade shows that actually happened. That's the thing I think is changing the most in our industry right now.
Yeah. Yeah.
There's the most impactful change.
I wasn't able to make it to Rapid this year, so I can't speak on that. But
Yeah.
maybe next year.
Yeah. But at Rapid, like, DuPont had a stand that was as big as Stratasys's, right?
Wow.
Yeah. Like, they went hard.
All right.
And it was full of, like, it wasn't just like there was the one scientist, you know, you know, like you go and you like visit a materials company, and there's the one person that knows like polymer chemistry, and he's like wheeled over to you when you ask a question. That one guy that knows something, you go there and they've got like this team of like 20 people, and it's like, this is the guy that knows a lot about coupling agents for coupling glass to polyamide 11. And then if you'd like to talk about coupling agents for composites to polyamide 6,6, you should go over there and talk to John. Like, and that's just the people that they brought to their trade show, right?
Right.
Yeah, these are like trillion-dollar companies. It's insane, and I am just so excited to see what they bring to the party, because it's going to get wild. I can assure you, it's going to get wild. Like, you know, in injection molded plastics, like having a part that's, you know, 15 gigapascals, it's not that big of a deal, you know, in flexural modulus and stiffness. It's just really not that big of a deal. But you know, in our neck of the woods, like, you know, everyone's like struggling to get above 5, like desperately, by adding carbon. And I've seen some things come from some of these big companies, and have printed them, and like, you can get bits of them, and it's one of the demo parts was a little, I don't know what you call it, but it's like you hold it with your thumbs and you ping it, and it goes like ping, 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 and you can play it kind of like a piano or a xylophone.
Okay.
But you flick it with your thumbnails. I don't know what it's called, but it's like, it basically is a musical instrument.
Yeah.
And it's just made of printed plastic. But you flick the little, they're like these little cantilevered beams, and you flick them down and let go of them with your fingernail, and they go pa-ting! Like they're made of metal.
Interesting.
Like, it's just so stiff, so stiff. Yeah. It's going to be a wild ride these next probably 2 years.
Nice. That's exciting. That's like the one thing that COVID did, was reminded everybody that 3D printing is the shit, and they probably need to support it, all their asses.
Yeah, it was amazing PR for our industry, right? Because like, just like boom, and then suddenly there was PPE. My wife was working in a hospital, and she works at a psych hospital, and you know, there are difficult patients, and they kind of worked out that by spitting they could you know, get past some of the security measures, or at least, you know, basically get their way when they shouldn't be getting their way. And then this, you know, a whole bunch of incidents, and I had printers running up at work because I'd already started churning them out. And I drove up to work at 2 a.m. I grabbed like everything that I could, and the parts that were next to the laser cutter, like shoved it all in a box, drove back down, and like gave the stuff to my wife, and you know, it was in use. And those were parts that had just been like kicked off that morning.
Yeah.
Like it was awesome.
It's very interesting. And I hope we don't ever have to do it again, but I know we're going to. All right. Well, with all that, thank you. I'm super thrilled to see what Assemble and the toolchanger brings in the future and what we do in the future. And yeah, I can't wait to have you back on the show to ramble again. So.
Yeah, thank you. I think we're most excited to see what the community do with Assemble.
For sure.
Cringe whether you think 3D printing, and we're so excited to see what the community do with this new product. It's PLA, but even oranger, and all your products can be even oranger than ever before. But like, no, in the truest sense of the word, like what the community do with it, like the code that they're going to contribute, the like being able to like figure out feeds and speeds for new materials, being able to like figure out new machining strategies that have never been conceived of before, because there are these like whole new application specific thing. Like that's what like that. Yes, that too. But like that is what community is amazing at, because there's no way that any one single person can ever know everything about 3D printing or about plastics or about machining. Any one of those subjects is something that requires a team in order to be truly like comprehensively well versed in. And you know, we at E3D, we have, you know, fingers in each of those pies, but nothing like what community can bring. And this is a whole new, like almost manufacturing process in a way.
Mm-hmm.
Yeah, we're combining two existing things, but like this is a whole new deal. And I'm genuinely excited to see both like the applications, but also the new like improvements and ways that this process can be improved. And the way that we're releasing Assemble is entirely designed to facilitate other people getting under the skin of how and why it works, and being able to change it.
Yes.
Open source, not just as in code, but as in like actually explain the thinking behind your product. Open source kind of thing.
Yes. Open source to enable, not open source to like.
Yeah, open as in academia, like as in open access research, like that. That's what we're trying to aim for here.
Awesome. All right. Well, with that, oh yeah, we have an exit thing. Keep making stuff.
This is the end of the podcast.
Thank you, guys. Cheers.
Thank you.